Hi friends, I'm Rahul and today I want to talk about physics again. In my previous video, I have stressed that it is really important for us to understand those principles which has been deduced by our forefathers in order to make our life more beautiful. So today I want to concentrate on science again, and today I want to talk about momentum and other things one by one. In my previous video, I have talked about kinematics, speed, velocity, distance, displacement, acceleration and other laws of motion, and today I will start from momentum. So what is momentum? Momentum is actually mass in motion. When an object which has certain mass and it is in motion with a certain velocity, then it has a momentum which is denoted by P, and it is equal to mass into velocity. So it is directly proportional to mass of the object and velocity of the object. If the mass is bigger, there will be more momentum associated with that object. So momentum is actually a vector quantity, and now I'm going to discuss how it is connected with impulse. Impulse is actually the change in momentum, and suppose there is an impact or collision where a force is acting for a certain period, a small amount of time, and it is changing the momentum of the object. Then the change in the momentum of the object is equal to the impulse. So from the Newton's second law of motion, where we know that force equal to mass into acceleration, where acceleration is the change in velocity divided by time. So if we equate this equation further, then F equal to mass into change in velocity, that is delta V by time. Then again we will go further, then force into time equal to mass into change into velocity. So that will be mass into change into velocity, that will change in momentum is equal to force into time, that is denoted by impulse. That force is acting for very specific period of time, that is called impulse. So impulse is nothing but the change in momentum. So there is very important law in physics that is called momentum conservation. So if there are two objects in motion, then after collision its momentum will be same which was prior to the collision, because in an isolated system where there is no air friction or there is no other net external force, so if there is two object in motion which has mass m1 and velocity u1, and second object has mass m2 and velocity v1, after collision it will have a different velocity. Suppose that v1 has been v2 now and u1 has been u2 now, then momentum m1 u1 plus m2 v1 equal to m2 u2 plus m2 v2. And don't forget the vector quantity, then vector will be denoted because it is momentum is a vector quantity. So the momentum is conserved in an isolated system. Isolated system, I have told that there will be no air friction or any kind of net external force outside external force, understand. So now in an explosion, we can say that momentum is also conserved in the case of explosion. In an explosion, what happens? If an object will explode, there will be some particles, then the momentum, if you will add, because it is a vector quantity, then vector sum of all those particles will give you the same momentum which it has prior to the explosion. So this is also conserved in the case of explosion. So I was thinking that if I will relate this conservation of momentum with the Big Bang, which happened actually 13 billion years before, was that we can relate that at that time momentum and this time after 13 billion years the momentum of the universe could be same, as I was thinking. But because Big Bang, scientists postulates that at the time of Big Bang the universe was contained in such a small volume, a trillion size of a dot that we can denote with a pen, and the energy contained within that volume was so high and hot that it is a quantum level, and quantum mechanics only can deal with that, and it can say an insight it can give only, and I am not there. So only if I will ask with my personal physicist, then we can have an answer. But I was thinking like that. But after Big Bang, what happened? The four forces came in nature, and there are many theories about that. Universe is in constant expansion, but it happened with a small amount of period. In early ages, when explosion happened, then after some fraction of second it got cooler, and some particle antimatter generated, and they collapsed, and thereafter particle generated, and boson and other things comes. This is a quantum level, so we can relate with that, but only quantum mechanics could tell about that. And the universe is in constant expansions, and even the expansion caused by dark energy. Scientists even don't know about what is dark matter and dark energy, because dark energy creates certain kind of vacuum energy, and we don't know about that, and the universe is still inexplicable, and the scientist is deducing one by one what could be explained, and they are explaining. So it might be that momentum would be conserved and it would be same, but I don't have an insight for that. This was an interesting point to bring this point, that's why I brought this point. And now I will talk about work. So what is work? Work is actually if a force acts upon an object and the objects get displaced, then we call that work has been done. But if a person is pushing a wall and wall is not get displaced, then there is no work done actually. If a lady is walking and on her head there is a basket and she is in a constant motion, but we cannot say that the work has been done, because the force which has been acting upward, it is not causing any kind of displacement, so there is no actually any kind of work done in that. But if we are pushing a table and the table is get displaced, then we can then tell that work has been done. And energy is the capacity of a physical system to do work. So energy is mainly categorized in two types, that is called potential energy and kinetic energy. And potential energy is actually the energy stored of position possessed by an object. There is an object suspended at a height, then it has a gravitational potential energy stored in it, that is called mgh. And if the height will be increased, there will be more potential energy stored in it, that will be called gravitational potential energy, and it is denoted by mass into z, gravitational energy, into h, height of that object, that is mgh, and that is called gravitational potential energy. And other kind of potential energy as elastic potential energy. If you are compressing an object which is elastic or stretching it, it stores energy, that is called elastic potential energy, and it is equal to half kx square, where x is the compression or stretching of that object, where k is the elastic constant. So now we know about potential energy, and there is a kind of energy that is called kinetic energy. The kinetic energy, whatever object it is in motion, then it has a kinetic energy. Either it is in vertical or in horizontal motion, it will have a kinetic energy, and that kinetic energy will be equal to half mv square. So today I want to close this chapter, but in next video I will discuss a very important point at how satellites get suspended in orbits around Earth and what it takes to get orbital velocity, and what are the concept behind it, what is the physics behind it. I will discuss about that, but before discussing that, we should have a prior knowledge of gravitation and circular motion, that means centripetal force. Then I will give you little insight about this interesting topic. But today I want to close this chapter. Thank you for listening to me and keep up with me. Thank you.